Dude, check out what I just drew. Oh yeah? Well, check this out. So we've all seen chemists scribbling lines and geometric shapes in textbooks or movie, but what do those lines really mean? In this video, we're going to break down bond line or skeletal formulas, the go-to way scientists efficiently draw complex molecules. Now, for starters, a simple single line represents a bond between an sp3 hybridized carbon and a hydrogen atom. If you look at the terminal point or at the end of those lines, it's basically a carbon with 3 hydrogens attached. However, if two lines meet at a vertex, that corner carbon has 2 hydrogens attached instead. Quick note, unless stated otherwise, hydrogens are implied in bond line structure, so don't go writing them out every time or it's going to be an eyesore. For example, let's look at this molecule. It has 5 carbons. You can count the 5 points in the structure, and that tells you how many carbons are in this molecule. If a structure consists of only single bonds with no functional groups attached, that is an alkane. The cool thing about alkanes, they're sp3 hybridized. This means that each carbon in the molecule forms 4 single sigma bonds, and those bonds are spread out over 4 electron densities. And when I say electron densities, I mean the regions around each carbon where the electrons hang out, not just the number of bonds. Next up, double bonds. These are alkenes, and they have sp2 hybridization. An sp2 hybridization carbon forms 3 sigma bonds and 1 pi bond. The pi bond overlap in a sideways fashion and are less of a direct contact, making them weaker. This causes you to get 3 electron densities in total, despite there being 4 bonds here. Then there are triple bonds, and these are alkynes. Alkynes are sp hybridized with 2 sigma bonds and 2 pi bonds, making for 2 electron densities. Let's talk about the prefixes. You'll see here's a quick chart showing the numerical prefixes and their corresponding number of carbons. So, looking back at our structure, 5 carbon, all single bonded with no funky additions. That's pentane, plain and simple. Alright, let's dive into something like this. This one might look a little funky, but here's the thing. We've got a double bond, so it's definitely an alkene of some sort. Count the points and you'll see that there are 7 carbons. Since the double bond is ambiguous unless it's specified otherwise, we can confidently call this heptene. And if there were a triple bond instead of a double bond, it'll be heptyne. But if the double or triple bond is not terminal, then the position is ambiguous without a number. So therefore, a number should be used. To wrap it all up, you can figure out the number of carbons just by counting the points in a structure. Each point represents a carbon-hydrogen single bond, sp3 hybridized, unless something more exciting is going on. If there's something more special going on, like a double or triple bond, the structure ending will reflect that. I hope this video helped you guys to get a clear idea of bond line structure and hybridization in a simple video.